Hello everybody, welcome to the online certification course on phase equilibrium thermodynamics, which is being offered by under the MOOCs platform. I am Prof Gargi, the course instructor of the course, and I will be assisted by Mr. Alex Gorgi and Dr. Shubhashish Mondal. All of us belong to the Department of Chemical Engineering of IIT Kharagpur. Now, the first thing which you would want to know from me is the motivation behind registering for this course. Now, as chemical engineers, we have to deal with a wide number of processes pertaining to fluid flow, heat transfer and mass transfer. One particular thing which distinguishes chemical engineers from the other disciplines of engineering and science is the mass transfer processes with or without chemical reactions for converting raw materials into useful products of greater value in an optimal fashion. For this, we need to design and develop new processes or improve the existing ones. Now, whenever we deal with the processes as is being shown in this particular display, we find that for all the processes we require the following information. Firstly, whether the process is feasible or not, and if it is feasible, how much energy is needed and what fraction of raw materials will be converted into the products. For example, in the toluene, suppose I have got a mixture of acetic acid and toluene, and I would like to use water as a solvent in order to remove acetic acid from toluene. Now, by this particular process, it is very difficult for me to obtain completely pure toluene. On the contrary, if I am using toluene to extract acetic acid from water, it is an impossible process. Again, in the distillation process, you see, when I am trying to separate ethanol from water, it is very difficult to obtain pure ethanol and pure water by this process. So, therefore, there are two. Also, we know that some chemical reactions are there which proceed in one direction, they do not proceed in the other reaction, while there are other chemical reactions which can be reversible. So, therefore, whenever we try to devise any particular mass transfer process, first thing we need to know is whether the process is feasible. If feasible, how much energy is needed and what is the equilibrium conversion, because that is the maximum that we can get out of the process. All these answers are provided by phase equilibrium thermodynamics, and I would like to emphasize that apart from chemical engineering students, several students who will be dealing with processes in their course curriculum or as part of their professional career will also be benefited by this course. For example, students from biochemical engineering, petroleum engineering, agriculture, mechanical and so on and so forth. We expect to provide a balanced coverage of physical concepts and mathematical operations along with examples and exercise problems of practical importance, such that you can use phase equilibrium to devise mass transfer equipments or to design proper mass transfer equipments. The course plan has been devised accordingly. I will be defining the concept of thermodynamic equilibrium in homogeneous closed systems, heterogeneous closed systems, homogeneous open systems. I will be trying to quantify equilibrium from the concept of chemical potential, fugacity. We will be dealing with both ideal and non-ideal solutions, and we will also be dealing with partially miscible and completely immiscible systems. And I will also try to touch upon a bit of hydrocarbon thermodynamics, since as chemical engineers, petroleum industries are quite a dream for us. The course is a 20 hours course spanning for 8 weeks, and just like all other MOOCs course, we will be having plenty of tutorials with practice problems as weekly assignments and a test at the end of the course. The relevant textbooks and reference books are as follows here. And with these few words, I welcome you to the online certification course on phase equilibrium thermodynamics. I expect to have a spontaneous interaction with you so that we finally attain thermodynamic equilibrium at the end of the process. Good luck. Welcome you all again. Have a good day.